Today I'm working on a Python data Capstone project. This project is called 911 calls and the data has been pulled from the Kaggle website. We will explore and analyze the data set to understand the density of the calls made during different hours of the day and different days of the week and months, where those calls are coming from and for what reasons, to help improve organizational efficiency. Please watch along if you find it interesting, or feel free to work alongside if you want to practice these codes too. The dataset has been linked in the description box in case you want to code along to practice your Python skills. You can download this dataset and move it in the same folder as the Jupyter notebook that you would be using. So let's get started. So here we will start by importing some libraries. Import numpy as np, import pandas as pd, import matplotlib dot pyplot as plt, import cbound as sns, and then we will run percent matplotlib space inline. This one line code is used to show the visualizations in the Jupyter notebook. Next, we will read the 911 calls CSV file as a data frame and we will name it as df. Just press tab as you begin typing, select read underscore CSV, then within inverted commas begin typing again and then press tab. It will auto complete the CSV file name and then enter. Now we will check the info of the data frame. So as we see here, this is a data frame which has 99,492 rows with row index ranging from 0 to 99,491, and there are 9 columns. We have latitude, longitude. These are float data. Then there's description. Let's do one thing. Let's check the head of this data frame as well. And now as you can see, we have this latitude and longitude column. Those are float data. There are no null values. Then we have description of the call, which again has no null values and it's given as an object. The string is always given as object data type in the data frame. Then we have zip column, which has some null values, as you can see one here. So here we only have 86,637 non-null values. That means there are about 13,000 or more null values in this zip column. Then we have title, which explain what kind of call that was. This is again an object. There are no null values. Then we have timestamp. This is again given as an object, so it is stored as a string. Then we have township and we have address and we have a column E which has no null values and it is an integer. I think it is always 1 as it is given in this data frame. Let's just quickly check that. We can do a value counts check. See, there are 99,492 ones. It's always 1. Now next we will begin analyzing this data. So first question is, what are the top 5 zip codes for 911 call? So we have our zip codes here. So here what we can do is we can do a value count for this column. So this will return a series with all the zip codes available with their frequency, and this frequency will always be arranged in a descending manner. If you check the signature of this method, we have this ascending parameter which is given as false. So by default the data will always be arranged in a descending manner. If you want the data to be in ascending order, that is going from least frequency to the most frequency, you can pass in this parameter ascending and return true for that. Here we only need the top 5, so we'll take a head of the series and we get our zip codes which has the maximum number of calls coming from those, and the answer here matches to our answer already given here in the Jupyter notebook. Next we have to do what are top 5 townships for 911 call. So we will use the same method here. Select township column, then do a value count, and we will use head method to get top 5 rows. And if you match the answers, we have the township as Lower Merion, Abington, Norristown, Upper Merion, and Cheltenham, and the data matches as well. Next, take a look at the title column. How many unique title codes there are? So let's check this title column first. So we have to find how many unique title codes there are. There are two ways we can do this. One is to use the unique method. This will return all the unique values in this series, and we can check the length of this array here, and that returns 110. The other method to do this is directly use the unique method, and it will directly return the number of unique values in that series. Next we have to create some new features. The title column there are reasons slash departments specified before the title code. These are EMS, fire, and traffic. Use.apply with a custom lambda expression to create a new column called reason that contains this string value. So here we have to create a new column with the name of the column being reason, and we have to take this title code and put this in the new column. So here call the column as if it's already exists, and then this will be based on the title column. We will, if you just use this, then in the reason you will have the exact same data which is there in the title column, but we will change that data here using the apply method. We will use a lambda expression for a custom defined function, and what that will do is when we take x, for x it will do a split, and here if you see this data here, we can split it with this colon, and what this will do I will show you first. Let's say this is x, and what is x? That will return the value in the first cell in that series. Now we can take this x and split it based on colon. So what this will do is it will split the string based on this colon. Everything before this colon will become one string, and everything after this colon will become another string. Now we need this EMS here, so we can index it to get this element. Now it will return only EMS. So this is what we have to do here. So we'll pass in this 0 index and run this. Now see what happens when I call this column reason. So it returns a series which has the EMS, fire, and traffic listed based on the title column. Let's check the head of the data frame. Here we have our new reason column, and the reasons are listed here taken from the title column. Next is, what is the most common reason for 911 call based off this new column? So once again we can do value count here, and here there are only three values: EMS, traffic and fire, and we have the frequency of those. So the most common reason for 911 call was the EMS, that is emergency medical service. Next was traffic, and the list was fire, and by some fair distance. So most of the calls were made for EMS, followed by traffic, followed by fire. Now use cbound to create a plot count plot of 911 calls by reason. So what we will do here is sns.countplot, and if you check the signature, we need to pass in a data frame. Then we will pass in either one of x or y. Because this is a count plot, if you pass in the x, the y would obviously be count, and if you pass in the y, it will plot horizontal plots and x will be the count. Our data frame is df, and on x we have to pass it by reason. So this is our data frame. So there are a couple of things to note here. One is all of these are in blue color. If you want this color palette, this is Viridis palette. So we can pass this here. So ignore this warning. We got our color parameter matching what is given here already. Now notice the background, that is white grid style, and here we have just white background. So we can change that. We can change the figure size as well, and notice the levels and data given on the x-axis and y-axis is much bigger, and here it is smaller. So we want to adjust these three things. So what we can do here is we can define those parameters. We will go back to the top of the notebook, because those would be global parameters. Insert a column. The first thing we will define is the figure size. For that we will use plt.rc params. Select this and then press tab. Start typing figure, then press tab. Will select the figure size and then define the size you want. Pass in the coordinates for that. So here we will uh, let me go with 4.5 and 3.5. That is the size of the figure in width and height that I want. Then the next is I want to set style for the notebook. Here there are two parameters, style and RC. If you go down and check the style, we have these four options given here: dark grid, dark white and ticks. What we have currently by default is white, and what we are looking to change this to is white grid. So we'll pass in that. Next we will select context. Here we have a context parameter, and then we have a font scale. If you go down and check, so here as you can see we have four options given from paper, notebook, talk and poster. As you go from left to right, the font size will become bigger and bigger. The options given for talk and poster are very good if your audience is far away from the visualization and you want them to read what is there on the x-axis and on the y-axis. For normal purpose, just for using Jupyter notebook, we can use paper and notebook. So here I will use the context notebook, and then for font scale I will make it 0.7. Now this will be global. Now all of the visualizations that I plot today will be based on these parameters. Let's go back to our uh, count plot. Let's run this again and see. Now the size has become smaller and the background has become white grid, and the data on the x level and y level has become have become smaller as well. So what we notice here is, if you look at the number of calls by EMS, that is about 40,000 something, less than 50,000. For fire it was about 1400, and for traffic it is less than 40,000, so about 35,000 something, and that's the same data we have got here, but visually we can see the difference between these. Now let us begin to focus on time information. What is the data type of the object in the timestamp column? So let's check the data in the timestamp column now. Press tab, press enter, and this will return all the data in this column. What we could do is use dtype, and this is returning an object. And as I said earlier, Python data frame by default stores all the strings as object. So to check the exact data type, what you could do is select an individual cell in this column and pass this through type, and this will return a string. Now we want to convert that into a date time object. What we could do here is use pd with method pd.to_datetime. We have this options here to convert the data. Here we will use the datetime method and pass in that data. Now let's check that data. And see, when we use the exact same uh, code earlier, we got data type as object. Now it is returning data type as a timestamp. We can further check the individual data in this column, and this will return a timestamp type. Now we can grab specific attributes from datetime object by calling them, for example. So let's check this. Pass this timestamp as time. Run this. So here let's call this time object, and we can check various attributes of this. For example, you can pass in hour here, and it will return the hour of the time. Let's check the actual time object. So this, as you see, is a timestamp object which has the actual date and time for that particular row. If you call the hour of that, it will return the hour as 17. If you call the month, it will return 12, which was the month. You can also call in the month name, pass this as callable function, and it will return December. You can press tab and check various methods which are given here. You can check if the time was a leap year, was the month end, month start, quarter end, quarter start. All of these are options. What year it was, what month, what date, what hour and minute, all of those options are available. So it returns the fourth quarter as it is December. So this column now is a date time object. We have to use the apply method to create three new columns called hour, month and day of the week. You will create these columns based off of the timestamp column. So what we have to do here is create new columns, one for hour, one for month and one day of the week based on this column, timestamp column. So what we will do is take our timestamp column, use the apply method, pass in the lambda expression, and for the data what we have to do is take that data and use .r method and this will return the R as we saw here to this column. And we could do the same thing for month as well. And day of week as well. Now let's check the data frame again. So as you can see here, we have got our additional columns for hour, month and day of week. The hour column has the hour data from the timestamp in each row. The month column has the month data, and day of the week has the day of the week data, but it is given as number. So notice how the day of the week is an integer given between 0 and 6. Let's check this. Yeah, so we have day of the week as given between 1 to 6, and 0 is there as well. So 0 to 6, and the frequency of each is given here, and the data is an integer. So notice how the day of the week is an integer 0 to 6. Use dot map with this dictionary to map the actual string names to the day of the week. So what we are going to do is we will change this day of the week column from the integer to this actual day of the week, which we could read and is a lot more intuitive. So take this column, day of the week. We will use the map function, and here we will pass in this, but first we have to run this dictionary here. Now pass this dictionary object inside this mapping function, and let's check our data frame again. And you see how all of those integers are now converted to the actual day of the week. Let's do a value count again to see the values. And now those integers are given as actual days of the week. Here it was given that 0 is Monday, so week starts from Monday, and this 0 to 6 is actually a range index going from 0 to 6. So first day is Monday, that is 0, Tuesday is 1, Wednesday is 2, 3 for Thursday, 4 for Friday, 5 for Saturday, and 6 for Sunday. Now use Seaborn to create a count plot of the day of the week column with the hue based off reason columns. So let's do that. We'll call the count plot. Here we have to pass our data frame. Then on the x-axis we have to pass the column based on which we want this plot. So let's pass day of the week, and let's see what this produces. So see here the days are not arranged properly, but what we have is it start on a high note on Monday, Tuesday, Wednesday, and then Thursday, Friday, and goes down on Saturday and Sunday. Now we need this based on hue as well for different reason. So let's use this color map by passing in the palette, which is Viridis, and then so here we will now move this legend box outside the actual graph. So for this we'll use plt.legend, and use the parameter bbox to anchor and pass in a tuple where you want it to be. So I want it just outside uh, this x coordinate and at the top of the y coordinate. So let's check what this does. Yeah, so now it is outside. This is good. So the question was to use Seaborn to create a count plot of the day of the week column with the hue based off the reason column. So here, if you check this graph based on the day data, we see the fire call is somewhere around 2000 each day. If you go back to our previous count plot, this was based on overall data. For entire data set, we had about 50,000 calls for EMS, about 14,000 calls for count, and about 35,000 calls for traffic. Now, when we plot this by day, what we found was the this dark green is fire. The fire calls were consistently around 2000 mark on each day of the week. This light green is traffic, which is higher on Thursday and Friday and then goes down on Saturday and Sunday and then again up on Monday, Tuesday, Wednesday. So basically on the weekdays we have more calls on Monday, Tuesday, Wednesday and Thursday and Friday here, and it goes down on the weekend. And kind of similar pattern is observed for the EMS calls as well, but to much lesser extent than compared to the traffic. Now let's move on. We will do the same for the month data. What we did here was we used the count plot for day of the week. Now let's check for the monthly data now. If you check our data frame, we have an hour column, we added an hour column, we added a month column, and we added a day of the week column. So let's check for the monthly data now. So here the for the legend, just the BB box argument was not working. What BB box to anchor does is it puts an anchor somewhere around this point, and then we can move the location. Just how we can move this legend using the location inside the actual graph itself using different numbers from 0 to 10. Similarly, we can move it around this anchor point as well. So 2 is on the upper right side and we got our legend outside the main graph. Now here, once again, if you see based on this monthly data, this is going from 1, 2, 3, 4, 5, 6, 7, 8, and then we don't have 9, 10, and 11. That is September. We don't have September, October, and November data. So as the year goes on, we see the number of calls comes down, and we see this pattern for all three reasons, whether those be EMS or traffic, which is in light green, or for fire, which is in dark green. So we will do one thing. Did you notice something strange about the plot? You should have noticed it was missing some months. Let's see if we can maybe fill in this information by plotting the information in another way, possibly a simple line plot that fills in the missing months. In order to do in order to do this, we will need to do some work with pandas. But before that, this video is getting too long, so we will take a break now. I am going to end this video here and will continue the rest of the exercise in part 2 video that will be linked at the end of this video and also in the description and comment box. So please continue with that. For now, thanks for watching.